Alrighty, so with this problem, she's traveling to a restaurant at 9 miles per hour one way and 15 miles per hour back the other way. And it's asking to find T1 and T2, which are the times, how much time she spends on the first path and how much time she spends on the second path. So we'll refer T1 to this path and T2 to this path. Now, one thing that's interesting about this problem is that you have a delta x, or a distance that is essentially equal in both directions. She's traveling the same distance to there and the same distance back, which we'll call delta x. Now, we have an equation of motion in which delta x is equal to vt, which is the velocity times the time traveled. That's one of the linear equations of straight line motion. And what you can say is that since delta x is equal to the first velocity times the first time, and delta x is also equal to the second velocity times the second time traveled, we can say these two equations are equal. So v1 t1 is equal to v2 t2. Now, given that, we can say, okay, well, v1 divided by v2 is equal to t1 over t2. All right, and what is v1 divided by v2? Well, that's 9 divided by 15. Sorry, this is t2 and this is t1. I'm sorry about that. Let me just erase that subscript and replace them. So this is T2 and T1. And now we have some sort of ratio for T2 to T1. But the thing about this fraction is that it can be reduced. So 9 divided by 15 is going to be 3 divided by 5. Okay. And what is the condition here? Well, the condition is that the time she travels is a total of 8 hours. So mathematically speaking, that should be T1 plus T2. The total time is going to be 8 hours. And if this is a 3 to 5 ratio, then this should be 5 plus 3 is 8. So it checks out. So basically, T1, she traveled 5 hours, and for the second block she traveled 3 hours. And does that make sense? Yes, she's going at a faster speed on the second path, so it's going to take a shorter amount of time than the first path. All right, that answers your question, so have a good one.